see, here we're going to see the conclusion of the bounce, wiggle, cross. So we are now going to go the other direction. So we are going to start with the equation. We're going to find the x-intercepts first. By the way, x-intercepts are the same thing as zeros. And then we're going to determine if it's going to bounce, wiggle, cross. We're going to do that by looking at the exponent attached to the factor. And then we're going to find the end behavior. We're going to put all the pieces together to make our graph. The goal is to do it without our calculator. So I like to do this just going in order from left to right. And you'll notice that I did some color coding with some highlighters at the start here just to show the difference between the different factors. So the first factor we have is x squared. The x-intercept associated with that is 0. And the exponent attached to it is 2. And so anytime it's an even exponent, it's going to bounce. The next factor we see is x plus 1. We're going to change it to the opposite sign to get the x-intercept, which is -1. The exponent is 3. When we have an exponent of 3, it's going to wiggle at the x-intercept. The third one we have here is x plus 2. Make it the opposite sign, so the x-intercept is -2. That one is being squared, so that one's going to be another bounce. And the final factor is x minus 3. We're going to change it to +3. The exponent attached to this factor is an invisible 1. Anytime it's an exponent of 1, here we're going to cross. Sorry about that, Val. Okay, so the next piece here, just to get it set up for the x-intercepts, this is what I like to do, and I want you to do the same on yours. So I'm going to start by showing an x-intercept of 0 right here, and I want you to put a b underneath it to remind us that it's going to bounce there. Let's do an x-intercept at -1. Write a w there, that's going to wiggle. X-intercept of -2, that one's going to bounce, so put a b. Last one over here, x-intercept of 3, it's going to cross. So we're going to come back to that in just a moment. That's just our clues to know what's happening for the inside part of our graph. The final thing we need to do now is the end behavior. So we need to figure out the leading coefficient and the degree. Because this one is in factored form, it's factored form because of the parentheses. This is where we need to add the exponents to get the degree. So we're going to be doing 2 plus 3 plus 2 plus 1. So that's going to give us a degree of 8, which is even. And then the leading coefficient out in front is +1. So positive leading coefficient, even degree, it's kind of like the graph of y equals x squared. That end behavior is going to be up, up. So what I like to do here for the end behavior is go to the far left. Right above that, just do a little arrow that's up. Go to the far right on this side and do a little arrow that's going up. Now we're just going to draw the inside using the bounce, wiggle, cross clues that we already created for ourselves. So starting here on this left side from the arrow, first x-intercept, it's going to bounce. Now, in order for it to come down and wiggle through the next one, that line has to turn around. So we need to have a turning point so that it can go down and wiggle through the next x-intercept. So we're going to turn it around, and when you bring it down to the x-axis, try to bring it down a little before the x-intercept so that you can show that it's getting flat at the x-intercept before bringing it down again. So it may be a little hard to show at first. You'll get better at it the more you do. We want to show that bend there for the wiggle. Now again, in order for it to bounce through the next one, it's going to have to turn around again so that it can bounce. And then finally, for it to cross through the last piece, it has to turn around again. And it's just going to perfectly cross through, connecting with the other arrow that we originally drew for the end behavior. Okay, so let's take a look at the next one. We have 4 different factors again, so we're going to have 4 x-intercepts, but what's happening in the graph here is going to look a little different. So starting with x cubed, that's an x-intercept of 0. It's exponent of 3, so it's going to wiggle. The next one, x minus 1, we're going to turn it to +1. It's being squared, so it's going to bounce. The x plus 3, we're going to make it -3. That one's going to cross because it's just an exponent of 1. And then the x minus 2 is going to turn into positive 2. That one's being squared, so it's going to bounce. Okay, so let's start to put this here on our graph. So at 0, it's going to wiggle. At 1, it's going to bounce. At -3, we have a cross. And at positive 2, we have a bounce. Okay, the leading coefficient is positive 1 again. Let's look at the degree. We're going to add all the exponents, 3 plus 2 plus 1. So that gets us up to 6 plus 2 again, so we have another degree of 8. So again, our end behavior is going to be up, up. So let's put those arrows on like we did the last time. Okay, so from this first arrow, it's going to cross through. It's got to turn around so that it can wiggle through 0. Turn around so it can bounce at 1. Turn around again so it can bounce at 2, connecting to the last arrow. Okay, just as we would do in class, I really want you to try this next one on your own. So that means I want you to pause the video right now, press pause, take a few minutes to try it, and then I want you to restart the video. Okay, so as you were working, I also paused mine and I started to get this filled in. So let's just use this as a chance to double check our answers. So x-intercept 0 is going to wiggle, -1 it's a bounce, -2 is a cross, and 3 is also a cross. The leading coefficient is 1 again, but this time the degree is 7. It's an odd degree, positive leading coefficient, so it's down up. So it's going to start down here, cross through -2, turn around, bounces at -1, turn around, wiggles through 0, turns around again to cross through 3. So that's how we can go the other direction to make a sketch of our graph just by looking at the equation. Okay, so for this next piece, we're practicing like looking at the graph, writing an equation in factored form. We're going to start by assuming that each tick mark is 1. So working backwards, I like to do some labeling, kind of like the labeling I just showed you in the last set. So I like to do two things. I'll put a dot for the x-intercept. I'm going to write the number of the x-intercept, so this is -4, and then I can see that it's crossing there, so I'm going to do a C. Right here we have an x-intercept of -1. Right there it's going to bounce. And then over here we've got an x-intercept of 3. See how it gets a little flat there? So that's a wiggle. Okay, so let's write our equation. So for the -4, we have to change it into x plus 4. It's a cross, so that exponent's 1. You can write it there, or you can keep it invisible. Okay, -1 is going to turn into x plus 1. It's a bounce, so it's going to be squared. And then +3 is going to turn into x minus 3. It's a wiggle, so it's going to be to the third. Let's do one more together. On this next one here, we have an x-intercept of 0. It's a wiggle. 3 is a cross. 4 is also a cross. So for the 0, we're just going to do x. We don't need parentheses there. It's like x minus 0 in parentheses. So we just have x. It's a wiggle, so it's x to the third. And then for the 3, we got to make it x minus 3, opposite sign. It's a cross, so it's just to the first power, but you also can make the 1 invisible. And then for the last parenthesis, x minus 4 to go with the +4, and that one's a cross as well. Okay, so again, I want you to pause this. This is what we would do in class. I want you to try the third one on your own, and then restart the video after you tried it. Okay, so if you're coming back to the video, you should have tried this last one on your own. It looks like we've got a bounce at -3. We've got a cross at 1, and we have another cross at 3. So we're going to do x plus 3 for the -3. We're going to make it squared because it's a bounce. X minus 1 to the first power for the cross, and then x minus 3 to the first power for the cross. Now for the last part, it says assume that each tick mark is 4. How we'll write the equations is that, well, instead of these being the way that we originally labeled them, if each tick mark represents 4 spaces, this would actually be -16 instead of -4. This one would actually be -4 instead of -1. Over here, that would actually be 12 instead of 3. So it's very simple. We're just going to multiply all of the numbers that we had before, we're just going to multiply them all by 4. Otherwise, it's going to look essentially the same. Okay, let's go ahead and move on to the back side. So the last part of this is a little summary. Here we're going to reiterate some things that we've talked about already. We're going to add in one new piece of vocabulary that's going to be really important as we move forward in working with these polynomial graphs. So to find the x-intercepts, and I want you to write in parentheses that x-intercepts are also called zeros. We saw a little bit of that back in chapter 4. To find those, we are essentially determining what x value will make the polynomial equal to 0, factor the polynomial if needed, then set each factor equal to 0, and solve for x. So if we think back to what we were doing earlier on in the investigation, something like x minus 1 squared times the quantity x plus 1 squared. So we know that the x-intercepts are going to be positive 1 from the first factor, negative 1 from the second factor. The reason that's happening is because the y value of an x-intercept is 0. So if we actually replace y with 0, we're actually solving this equation when what x values would make it so that it's equal to 0. We're going to do the zero product property, just like we did when we were solving quadratic equations. If we set x minus 1 equal to 0 and solve for x, we get positive 1. Over here, if we set x plus 1 equal to 0 and solve for x, we get negative 1. That's why the sign changes to the opposite side. Okay, let's look at number 2. Sometimes a 0 repeats. Let's say you had the polynomial x minus 3 times x minus 3 times x minus 3. Another way to write that would be y equals the quantity x minus 3 cubed with an exponent. And so the number of times that a 0 repeats is called the multiplicity. And all you need to do is look at the exponent attached to each factor to see its multiplicity. So, for example, in the previous one, it would have a multiplicity of 3. That's the exponent that's attached to the factor. So up until this point, we've been using the word exponent. We said, hey, even exponents, it's going to bounce. Well, now we're going to say if the multiplicity is even, it's going to bounce. And that's exactly actually where we're headed in the next part. Let's fill in 6 since that's what I just said. If the multiplicity is even, the graph will bounce on the x-intercept. If the multiplicity is odd and greater than 1, the graph will wiggle through the x-intercept. And then finally, if the multiplicity equals exactly 1, that's like the linear factor, it's just going to perfectly cross through the x-intercept. Okay, so multiplicity, that's the big new word that we need to take from this. So moving forward, we're going to put all the pieces together. Multiplicity, we're going to add one other element to this, which is the y-intercept. So we're going to talk a little bit about how that will come into play in sketching our graph. Okay, so going in order of what it's asking us for here, let's start by thinking about the end behavior. This one is in factored form. It has parentheses. So to get the degree, we're going to add the exponents that are attached to each factor. 1 plus 2 gives us a degree of 3. The leading coefficient is the number out in front of the first factor. In this case, it's an invisible positive 1. So positive leading coefficient, odd degree, the end behavior is going to be down up. Zeros, that's another word for x-intercept. So from x minus 2, we have an x-intercept of positive 2. The multiplicity is 1. That's the exponent attached to the factor. And because the multiplicity is 1, it's going to cross. The other x-intercept, the other 0, is negative 3. It has a multiplicity of 2, and so it's going to bounce. Y-intercept is the same as what we've always done before in the past. We're going to plug in 0 for x and solve for y. So we have y equals the quantity 0 minus 2 times the quantity 0 plus 3 squared. So this gives us negative 2 times 3 squared. We're going to do order of operations here, so do 3 squared, which is 9. Multiply 9 by negative 2, and that gives us a y-intercept of negative 18. Okay, so now we're going to sketch our graph. So you are going to go ahead and draw in your x and y axis. Let's put in some tick marks on the x-axis to show the x-intercepts. So we have an x-intercept of 2, and it's going to cross there. We have another x-intercept at negative 3, and it's going to bounce. The end behavior is down up, so let's do a down arrow down here. We'll do an up arrow over there. And then we also know the y-intercept is negative 18. So you don't need to do individual tick marks on your y-axis. But I do want you to plot and label a point that can represent the y-intercept value. So in this case, that'll be negative 18. Okay, so now let's go ahead and start to connect it. So it's going to bounce. It has to turn around so that it can go through that y-intercept. Whoa, my pen is not cooperating. It's like slower than how I'm writing it on this tablet. So let me try this again. So it's going to bounce there. And I want it to, oh my gosh, you guys, this is horrible. Okay, this pen does not want to work, but pretend like that just went through negative 18. Yours is going to be much prettier than mine. And that is the full sketch of our graph. Okay, let's try one more. Oh, hold on. Okay, see this pen went backwards instead of forwards. Okay, so let's try this last one. So end behavior, let's look at the degree. So we're going to add our exponents. So we are going to add 1 plus 1 plus 2 plus 3. That ends up being a degree of 7. Oh my gosh, I might have to pause this and try it again. This pen is being so slow. Let me pause this. Hopefully when I come back, I can get it to work properly. Okay, I think this should work better now. So we have a degree of 7. Leading coefficient is 1, so this one is going to be down up. Oh, I guess I could have written that over here where it says end behavior. Okay, so let's go to our zeros. So the first factor is x, so the 0 is 0. Multiplicity is 1, so it's going to cross. X minus 5, we're going to turn it into positive 5. Multiplicity is 1, so this one is also going to cross. X plus 4, we'll turn it into negative 4. Multiplicity is 2, so it's a bounce. And then x plus 1, turn it into negative 1. Multiplicity is 3, so this one is going to wiggle. Okay, this one is going to be the same process for getting the y-intercept as we did before, plugging in 0 for x. So we have 0 times 0 minus 5 times 0 plus 4 squared times 0 plus 1 cubed. At first glance, this one looks like, oh gosh, this one might be more work. Oh, sorry for the bell. But this one actually ends up being really easy because we have the 0 out in the very, very front. 0 times anything is 0, so it's going to wipe everything out. Another clue here is that if you ever have an x-intercept of 0, your y-intercept will also be 0. Okay, so let's go ahead and start to draw our x and y axis in for the sketch of a graph. So at 0, it's going to cross. Over here, let's do 1, 2, 3, 4, 5. At 5, it's also going to cross. At negative 4, it's going to bounce. And then at negative 1, it's going to wiggle. All right, let's do our end behavior down, up. We don't need to worry about putting the y-intercept in because it's already represented there, 0, 0. Okay, so let's go ahead and start to draw our curve. So it's going to bounce at negative 4, come down, turn around so that it can wiggle. Wait, yeah, it's going to wiggle through negative 1. So it's going to look like that. It's got to turn around so that it can cross through 0, and then it'll turn around one more time so that it can cross through 5. Okay, not super pretty. Do the best you can in sketching it on your own. I do think the elements, like the wiggle, will get easier to draw over time with more practice. So that is the conclusion of Bounce, Wiggle, Cross. Thank you for watching, and you should have all the information you need now to do the 5.2 Pocket worksheet. That'll be the homework assignment for this lesson.